Hello everyone and welcome back to another Universe Sandbox video, and today we're going to be continuing on with evolving the solar system itself from the present day to death. So if you remember last episode, definitely go ahead and check it out first. But remember, Earth, we had its constants evolve, and then slowly the greenhouse effect went higher and higher. We lost water, the atmosphere changed, obviously the water all evaporated. Then we had the same sort of story with Mars, where we brought some water onto Mars, and then obviously that has all pretty much disappeared at this point. I think what's Mars at? Mars is currently at 82 degrees and increasing right now. Even since I've just pressed play today, it's already increasing. So yeah, Mars lost its water. Same sort of story as Earth. Just all evaporated away really. So yeah, Mars is just barren. No water left at all now. Quite a shame, but obviously I don't think Mars will be lasting as long as Earth anytime soon with its water, since obviously the Sun at this point is evolving a lot quicker than it once would have been. So Mars will be habitable for a less amount of time. So there is that. So I don't know, should I keep the atmosphere thick or not? I mean, I don't know, because Mars probably wouldn't end up with thick atmospheres like Earth or Venus. Maybe it just loses its atmosphere a little more. So maybe it just looks more like that. So, you know, it's not on the level of Earth or Venus with its just intense thick atmosphere. So maybe something in between like this would be more appropriate for Mars' appearance. But yeah, we'll leave that alone. So anyways, onto the Sun itself. So we're just going to continually, now we're going to start getting into the proper red giant stuff. So we're going to be looking past the inner solar system to more of the outer solar system now, and seeing what will sort of go on over there. So maybe we'll add some moons and stuff in and see how they survive. But anyways, the Sun, we're going to just do a straight up double up in radius, and then luminosity we're going to put up to about 10 suns now. So yeah, Sun's getting a lot bigger and a lot more nasty. So as you can see here, if we actually put this as 8.55 times larger than Sun is normally. So you can see Mercury, it looks like it's losing material now. Not good. Sun is getting extremely dangerous. And poor old Mercury is going to be the first one to get it, unfortunately. So, yeah, not looking good here. So, let's let time evolve. Keep an eye on Mercury. What we'll do is we can probably put the good old temperatures back up, actually. So let's go ahead and do that. So we'll just keep an eye on the temperature list. You can see Mercury's hottest point going into the 600s now. So pretty crazy. There's Venus. You can spot Venus and Earth just because they're glowing hot. So pretty wild stuff. Venus, yeah. Let's go ahead and do that. Then we got the Earth. So Earth is actually hotter than Venus because it actually has more CO2, so the greenhouse effect on Earth is actually even more insane than Venus. So yeah, not looking good on Earth whatsoever. And then Mars, next object out, nowhere near as hot as all the other planets at its present moment in time. So there we are. So there we go, Mars. So yeah, the inner three planets, they're a lot hot, and then Mars is just chilling at 140 degrees. But some of the colder areas of Mars, yeah, I mean, they go down to about, 3 degrees at the absolute coldest points. So, not much going on there. Oh, look, those two little... Do you see those dark blue dots? What exactly are those, and why are they so cold? Oh, they're the volcanoes. So, the top of the volcanoes are the only sort of cold place on Mars. They're at 4 degrees. So, the top of Olympus Mons, that is effectively the coldest place on Mars at the moment. So, pretty crazy stuff. Okay. So if we actually get a lineup of actually have a closer look at Earth, for instance. So yeah, nothing. Yeah, not looking good whatsoever there. So the greenhouse effect is just too much for Earth to handle. Same with Venus. Venus is obviously evolving more naturally because it hasn't had any human interaction on it to give it more CO2. So hence it's not as hot. But yeah, still pretty crazy at Venus, as you can see here. And then obviously Mercury, that's obviously warming up still. Anyway, so let's go ahead and actually just let the time play out. Slowly watch as temperatures increase and change. It's cool how all this works, isn't it? I mean, look at that. That is so cool. You can see the areas on Olympus Mons are constantly changing due to Mars's rotational period and its tilt and all that. So you can see it is sort of changing. Same with Earth. You can see the seasons on Earth are going up and down slightly due to Earth's tilt. Venus and Mercury are more just... They don't really have much of a tilt at all. So they're just sort of consistently the same. But yeah, Earth and Mars on their slight tilts, that does make the seasons change. You can sort of see the difference between the summers and the winters in the north and south. That's pretty cool. See, Mars at the moment is in the summer, now it's in the winter, and then back to the summer again. That's cool. So yeah, pretty well. But even in the summer, 22 degrees is the hottest sort of point on Mars. So pretty crazy stuff there. Anyways, That's the inner solar system. So, the outer solar system. Well, first we'll take a little stop to Ceres, actually. I want to see how Ceres is doing. So, where are we? Ceres? God, where's Ceres? Let's put the labels on. Ceres? Where's Ceres? What's going on here? Is Ceres deleted? What? Why is Ceres not in here? Oh. I don't know why Ceres isn't in here. I guess we'll throw one in somewhere. I mean, its orbit isn't going to be exactly correct, but we'll just go ahead and do it anyway. Let's go ahead and spawn Ceres in. Maybe it just dissolved. I have no idea, so let's just place it. I don't know. But we know it's in the asteroid belt roughly, so let's place it there. Okay, so Ceres, how are you doing? Let's see how Ceres sort of warms up here. So, obviously, next object out, or next major, or mostly major object out from Mars. Let's see where Ceres sort of ends up in temperature. So, it is going into the positive temperatures. So, you know, pretty crazy stuff here. So, I guess we could probably add Ceres to our little collection of stuff here. So, there we go. Oh, no, I need the temperature one, don't I? What am I doing? We need that one. There we go. See how that sort of behaves. There we go. It doesn't really have a proper surface texture Ceres, so it's a little different. But so the hottest point is now 40 degrees on Ceres. So yeah, really. So that's effectively hotter than the Earth is today. So pretty wild stuff there. So there's Ceres. But now moving on to Jupiter. So the first of the outer solar system. So we can see Jupiter slowly but surely is warming up. So let's just let time play out a lot and see how high Jupiter will go. Okay, so we can see now its warmest point is about minus 57 degrees or average. So pretty crazy stuff there. Look how cool that looks. that map with all the extra bands, that looks awesome. So if we just look at Jupiter here though, surface temperature. So yeah, even the hottest points, yeah, not enough yet. So pretty crazy there. So the sun. Again, I think it's just required more and more now that it's going to start getting very sort of crazy now. So we're going to double up that luminosity straight up and increase it just a tad more as time goes on, because now it really is hammer time for the solar system. You can see things are changing a lot. Jupiter is now going into the positive temperatures. You can see the hottest points on Jupiter are going into on the actual equator of Jupiter is reaching sort of higher temperatures now. Pretty crazy stuff. So if we actually look at the sun from Jupiter, how large is the sun now? So let's turn all this off. So the sun's larger than it is, or than it appears to probably Mercury or Venus in the present day. So yeah, sun's pretty crazy. You can see Venus and Earth are glowing, so you can spot those from Jupiter pretty easy. Can we spot Mercury? Oh, Mercury's probably completely lost in the glare of the sun at this point. Okay. Ah, there it is. So Mercury, how are you doing? 600 degrees. Yeah, I'm sure that's going to change very shortly. Whoa, whoa. I'm surprised it's not hotter. Honestly, I gotta be honest. I'm surprised Mercury isn't hotter at this point. So you can tell its hottest point is 1,000 degrees on the surface. So pretty wild stuff. Remember, Mercury's got like a weird tidal lock sort of system going on, so it's not always going to be scorched out as easy as the other planets, just due to its weird tidal locking. But even in the coldest points, it's still minus 90 degrees, I should say. How's Venus doing? Earth is at 2,000 degrees now, so pretty crazy stuff. And I think at this point is probably where the atmospheres of Venus and Earth are probably going to be completely worn away. So I think the appropriate thing to do here, so if we go to Venus, we're just going to turn atmosphere mass to 0. So we're going to completely wipe its atmosphere out. There you go. Whoa, 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 what's going on, Venus? What is that all about? Okay. I think what we'll have to do just to stop the visual glitch, just to put it just to 1. Wait. Can I have an atmosphere, please? And I think what we just need to simply do is just turn that off. And then put this back to 0 to stop that glitch happening. There we go. There you go, that's better. So no glitchy atmosphere anymore. So Venus's atmosphere completely eroded away. Nothing left. So there we go. And then the same story with Earth. I'm going to do the same with you. So, for instance, let's just turn atmosphere and clouds off. And then atmosphere mass is going straight to 0. Earth and Venus's atmosphere is completely wiped out. So we're going to see how these planets will change now. So they'll probably cool down and then start warming up again as the sun still gets really crazy. You can see Earth's max temperature is cooling down. So keep an eye on Earth and Venus on the grids here. So their atmosphere is completely eroded away. So you can see Earth is cooling down now. So let's see how that sort of settles. So there we go. Venus, same with Venus as well. Ooh, what's going on there? Ooh. So Earth's actually cooled down. Hey, and the same with Venus. I mean, it will still be hotter than Earth at this point, but yeah, Earth's actually cooled down a lot. So, oh wow, it actually has. So now it's lost that greenhouse effect. But again, the sun is merciless. It's not going to let you cool down that easy. So we're going to put the luminosity up to 40. Again, the sun is going to get even larger in size. And then I'm going to go ahead and save this simulation before, just in case, because remember, stars in this game can be a bit trouble. So let's go ahead and save. And then obviously we're going to buff that radius up big time as well now. So let's go very big. So there you go. Sun is getting very monstrous now. Mercury is on the right limit of existence. There you go. You can see it right over there. And now, pretty crazy stuff in there. Luminosity. That's just going to get very, very dangerous. So there you go. So yeah, Earth and Venus may have cooled down for now. But Sun's obviously getting very violently large. So let's go ahead and speed up properly. So you can see Earth and Venus's temperature, again, they are going to go extremely high. So Earth is actually hotter than Venus still, even though with no atmosphere interference now. Pretty interesting stuff there. I wonder why that is. Anyways, Mars, how are you doing? So again, yeah, Mars, I don't think its atmosphere would have completely eroded yet. I mean, it's further out than Mercury, Venus, and Earth, so maybe its atmosphere would last a little longer, but I mean, once it gets critical, I mean, I don't think the atmosphere of Mars will last at all there. So, pretty wild. How are we doing in the outer system? So we'll keep an eye on Jupiter, Ceres for now. We won't go as far out as Saturn. I mean, Saturn, how are you doing, actually? No, it's still not warmed up yet. Saturn still at minus 40, but let's just see. Let's let the simulation run for a bit. Will it warm up? No, it's not. It's still at minus 25 there. So where is the habitable zone at Saturn's point of view? So Saturn is on the far edges of the habitable disk. If we go to Jupiter, Jupiter's habitable disk is in the red now, so it's at 111 degrees at Jupiter there. How are we doing it? Uranus, I mean, Uranus is just nowhere near it yet, so there we go. But we will start to add Saturn to our little list here of stuff, so there we go. Keep an eye on Saturn. So Saturn is receiving some temperature. At its hottest points, it is receiving a bit. Okay. Whoa, everything's going really wild here. Look at Venus and Earth. What is that all about? Mercury, just crazy hot. But there we go. So Sun is getting just crazy. Maybe we give it a more reddish tint as well. Why not? Make it look extra scary. So there we go. Oh yeah, it looks menacing. Alright. So very red Sun. Okay. How you doing, Earth? So all that's left of the Earth. Remember, it's not the original Earth texture because its continents did change in the last episode. So it's just a completely random looking planet pretty much now. But there you go. So it is increasing up. Venus, how you doing? 442 degrees. Earth is at 580 at its hottest point. Earth's average is 505. What's Venus? Only Venus is cooled down. Why is that? Huh. Pretty weird stuff. But anyways, again, the Sun. Luminosity is getting extremely dangerous now. So if we look at the zone, for instance, Uranus may start to enter. No. Even then, Uranus not enough. Because remember, there's a big gap between Saturn and Uranus's distance. Remember, if we look at Saturn, it's roughly about 10 AU, 10 AU away. But Uranus is about 17, I think it is. 19 AU. So it's a big jump there. And obviously, Neptune's almost double the distance of Uranus. So it's pretty crazy stuff. Okay. Temperature-wise, Mercury is just not having a good time. Look at that, just due to its tidally locking effect. I mean, yeah, that's not too friendly looking, is it? So you can see, look, as the area goes into the daytime, you can see it just completely melts straight up. So poor old Mercury is just not in for a good time. Look at that. Look at the state of that. Oh, that's the Sun. Oh, damn. Okay, that's pretty wild. But remember, the Sun will continue to get bigger and bigger. So again, luminosity will start going into the sort of 500s now, and obviously radius. I think Mercury's going to start sort of seeing some trouble here, as the Sun does get so large that Mercury will probably start to eventually get completely dissolved or just crash into the Sun. So yeah, Mercury's right on the edge of its limits now, not looking good at all. So Mercury's at 2,600. We can see Earth and Venus back in the thousands, pretty much. Mars, 900 degrees. An increase in Jupiter, or Ceres, sorry, 500. Jupiter, 320 at its hottest. Even Saturn, 43 degrees and increasing. Uranus, where are you at? How are we doing now? Also, Uranus is entered the blue zone now, so we can start to see it. Maybe Uranus will start to look at that pale colour. But Uranus, yeah, it's got this weird tilt, remember, so Uranus's map is a bit weird. And Neptune, how are you doing over here? I mean, yeah, Neptune's not going to see anymore. How does the sun actually look from Neptune? So the most distant of the planets. Yeah, sun's just looking fine, isn't it? Oh, very red here. Okay. Where are we? So there's not really anything further out than Neptune we need to pay attention. I mean, Planet 9, I guess. See if light is reaching Planet 9 yet. Is it? It is! Planet 9 is receiving light for the first time in a very, very long time. So where is the sun? So even a red giant sun, you can barely see the sun from this distance. If I go to realistic, so you can see the sun, yeah, very, very distant. So yeah, pretty insane stuff there. But Planet 9 is receiving light. So maybe it'll warm up from that minus 263. Pretty wild there. Actually, Neptune. Actually, well, I'll get Neptune and Planet 9's temperatures up, so we can keep an eye on her, see if Planet 9 actually does get any sort of temperature at all. Because I mean, it's receiving light, so in theory, it's receiving energy. So Neptune, there you go. Look at that beautiful blue. Okay, and then lastly, Planet 9. I mean, why not? Where is Planet 9? Oh wait, where is it? Oh, there it is. So add that on. Says Planet 9's map, and then there you go. Okay, so. But you can see the equator is about 1 degree warmer than everywhere else. So, yeah, not much going on at Planet 9 yet. But yes, keep an eye on the Jupiter, Saturn, Uranus sort of looks at the moment. Also, Uranus is receiving temperature, 9 degrees. So, for the first time in probably a long time for Uranus, it's actually receiving temperature. So, there it is. It's tilted on its side, remember. But yeah, it's receiving that light, it's receiving that temperature, so it is warming up slowly but surely over at Uranus. Let's actually just let the simulation play out for a bit and also save. There you go. Okay, so we're really sort of near the end of the solar system now, so there we are. Okay, let's continue. How are we doing at the... Oh dear, oh my god. Things are getting pretty wild. Look at that. Oh my god. So anyways, Uranus. So 60 degrees at its hottest point now on the equator. Look at that. But obviously, as it goes around the sun, you can see that the hottest point does move around because now the north and south pole are switching which side is facing the sun. If we look at Uranus's axis here, you can see, obviously, say this, I think this is the north pole here, south pole on that side. So if we look as Uranus goes around the sun, you can see the north and south pole are going to swap where the hottest point is. So that's in between at the moment. Now the south pole, or whichever pole it is, north or south, is now going to receive the other set of light. So it's pretty crazy how Uranus works, isn't it? So tilted on its side there, pretty crazy. Neptune, how you doing? Nope, still no temperature at Neptune yet. And obviously nothing at Planet 9. Anyways, the inner solar system, so how are we doing? Right, so let's do this. Whoa, right. So, Mercury. It is end of the line for Mercury. We're going to let the sun increase more, slow down time. There we go, just go to a couple of hours, something like that, a little more. Okay, there you go. So, radius, 0.3 suns. But Mercury is not meant for this solar system anymore. It's just going to go into the sun. Any point now, probably. It look like, oh, that's crazy dangerous. So, I mean, I think at this point, it probably would just fall into the sun. So maybe we just lower its orbit down and down. Oh my god. So there you go, so nothing left here. I mean, look, it's all glitching out. It just can't handle it. So there we go. But maybe zero velocity. I think it's just going to get pulled in at this point. I mean, that is just... Ooh. So, Mercury. Let's keep an eye on the top there. So there you go. So it's just going to slowly get closer and closer till it goes in. So there you go. It's falling. We're only travelling at a couple of minutes here, but it is the end of the line for the first of the planets. So let's go ahead and slowly watch as it goes in. Oh, be cool if we can get the exact moment. There it goes, it's gone. Oh, and there you go. So you can see there's a collision on the sun's surface. There you go. So Mercury has been engulfed by the sun there. So big collision. That's created quite a big. Well, that's quite a big explosion actually. I mean, if you compare that, I mean that collision mark's bigger than the sun is in its current form. So, oh dear. So there you go. Okay, so Venus, closest planet to the sun now. So, again, I think radius is going to get more monstrous. There you go. Luminosity is now going into the probably up to 1,000 almost at this point. Pretty crazy stuff. So how are we looking at Earth and Venus now? I mean, Venus, Mars. I think at this point Mars's atmosphere would be completely eroded as well. Whatever's left of it anyway, so let's turn all that off. So no more atmosphere for Mars. There you go, 0. Done. So atmosphere on Mars, it is eroded, so it's going to lose a bit of temperature again. But it's obviously going to increase it anyway, because the sun is just monstery dangerous. No, it's still increasing. Doesn't matter if the atmosphere is gone. The sun is monstrous now. So there you go. Anyways, outer solar system. How are we looking down here? Neptune, is it receiving temperature yet? No, it is not. Not yet anyway. I reckon it's going to do very shortly. Let's hit the simulation play. 10 degrees, 9, 8, 7. Yeah, it's definitely, surely. And there you go. Neptune is now in the habitable zone, effectively. So there you are. Okay. So, good old Neptune receiving that habitable area around us. So let's actually have a look. So is it in the green? No, it's in the blue at the moment. Okay, how about Uranus? How are you doing? Oh, so Uranus is in the green as well. Average temperature. Okay. What about Saturn? How are you doing? Saturn's at 200 degrees, so I think Saturn would have passed the habitable zone at this point. Yeah, it would have. So, unfortunately, we've missed the little cut-off to do Titan, unfortunately. But, oh well. So, there you go. So, too hot here. If you were to spawn in Titan, it would just be... I mean, we'll quickly have a look at it, but, I mean, it's not going to... It's just going to go up to the high temperature, so we'll just go ahead and spawn it around Saturn. I'm not going for a realistic distance, so we'll just go ahead and put it there. Okay, so how you doing, Titan? Let's watch it warm up very quickly. See how sort of Titan plays out. So here it is. Yeah, 208 degrees at Titan, so it would have passed its habitable point, unfortunately. So there we go. Okay, cool. So Uranus, I mean, is there any moons around Uranus we could sort of maybe look at? I mean, 44 degrees. Obviously, at this point, Triton wouldn't orbit Neptune anymore, so we can't do that. It would have fallen into Neptune by this point in the future. So, yeah, unfortunately, we can't do that. Uranus doesn't really have any major moons that are really notable, actually. I mean, none of Uranus's major moons are really bad. I mean, they're probably quite a forgettable set of moons, to be honest. I mean, when you think of a moon in the solar system, you don't really think of anything around Uranus. Anyways, let's continue. Yeah, there's not really any sort of unique moon. You know, like, obviously, Jupiter, you've got the 4 Galilean moons. Saturn, you've got Titan, Enceladus, Mimas. Uranus, you have Miranda, I guess. But Miranda's so small, I mean, you wouldn't really ever be able to get much on there. And then obviously Triton around Neptune, but again, Triton at this point in the future wouldn't exist. It would have fallen into Neptune's Rouge limit by now. So unfortunately no Triton. So there we are. I guess we could look at Pluto. Any colonies on Pluto in the future? Maybe we could have a look at that. How is Pluto looking temperature wise? That's still very cold here. It is warming up though, Pluto. Good old Pluto. Okay. So if you look at the distance of the sun from Pluto's perspective, yeah, quite nice and bright. But is it enough for Pluto to actually warm up? That is the question. I mean, I don't know. We look here. Oh, I guess we've got Pluto now. Let's go ahead and have a look. So Pluto, no, it's receiving some light. Okay. So yeah, maybe at this point Pluto would be the place to stay. So there you go. So even though it's minus 12, it is receiving about 13 as its highest point. Okay, could possibly be some sort of life place there. Who knows? But yeah, there's Pluto. I mean, effectively, Pluto has a lot of frozen stuff. So maybe if we add a bit of water. And that's going to lose it. Actually, so what we need to do is, for convenience, let's try and add the magnetic field on. Because I know someone said this in the last video. And I did think about doing it, but I was like, I don't think it really makes too much difference. But I mean, we can try and add something, I guess. I don't know, one magnetic field and moon. Let's see that. There you go. It's got a little protection at least. Let's maybe just give it a bit more. But I don't think this is enough to actually support water, though. Because water in this game does work very strange. Yeah, it won't have it. Pluto just can't hold on. It hasn't got the mass, unfortunately, in this game. Oh, well. But yeah, maybe Pluto would look something like this in the future. Who knows? I don't think we're really going to be able to see it, unfortunately. But yeah, you guys have seen a colonized Pluto before, so there we are. But yeah, maybe Pluto would have received something at that point. Who knows? Let's just turn off that magnetic field as well. Where are we? Yeah, let's turn that off. Okay. Right, anyways, moving on. So, Sun. Let's continue doing this. Yeah, that's pretty crazy stuff. Planet 9, how you doing? Minus 250. Yes, there's still nothing at Planet 9. You know, there's just no... It's just too far away, even at sun at maximum limit. Yeah, insane stuff there. See, the orbits are still wobbling around as well. You know, that's not changed, even at this point in the future. So, there you go. Okay. Now, the question here is, will Venus survive the sun? Because most theories say that Venus won't. So, we're going to go with that theory. So, again, the sun is going to evolve more. But, as well, as the sun gets larger, smaller, because it's going to sort of puff up and down a bit like this. So, it's going to go up, down, as it's really sort of struggling to hang on. But while it's going up and down like this, so it's just sort of going up and down with its radius, as it's changing its internal sort of its internal gases and whatever, it's all its elements are changing, so it does puff up. So Venus has just been eaten there, but as it continually goes up, while it does this, it's actually going to push out the solar system a bit. So we're going to expand the system just by one, but we're going to press expand once. As the sun puffs up and down, it does push out some of the orbits. So now if we look at Earth, it has been pushed away. Whoa! Oi! What's that all about? Oi, sun! Come on! What? See, that's the problem in this game. Stars like to pop for no reason. So, very, very annoying stuff. But that's why we save. Because we weren't finished. We weren't finished there, game. Oi. Oi, there, where are we? So, where are we? Mercury's still in the sim? Yeah, it is. Okay, let's delete that. So maybe the collision caused it. See, I don't know, because sometimes when you collide something with stars, it can actually upset stuff. So let's actually just try and make it larger than Venus again. Double it up there, I guess, and then also expand the solar system. Let's see if it will survive doing that. So there we go. So if we look at Earth, for instance, now. So, where are my motion? So it's now 11.9. Okay, no, this hasn't expanded. Come on, oi. Well, actually, in theory, it has. But let's. Is that working? I want to. Oh, I'm doing auto orb. Oh, I've messed. Okay, no, we need to. I pressed the wrong button. We want to expand, not auto orbit, because that just changes all the. Oh dear. Right, let's do that again. Right, so Mercury, you've already been deleted. Venus has been deleted. Okay, right, so solar system. Right, tools, open tools, expand. There you go. So it's pushed everything out of it. So now if we look at Earth's orbit, so it should be 1.15. So yeah, it's been pushed out a bit. So I'm not going to go further than that, because it's not going to be pushing the Earth out to like 2 AU or anything like that, I don't think. So there you go. Okay, so is that all running? Yeah. Okay, so we're going to go ahead and save. Now we know that is running. So there you go. Oh, we lost all of our temperature grids as well. That's a bit annoying. But I mean, yeah, Neptune is pretty much the furthest we're going to see temperature really travel. So I mean, let's look at Neptune. How you doing? So Neptune, there it is. So even at its hottest points, oh yeah, because we had to downgrade the sun, didn't we? Let's pull it back where it was. So we're going up to about 1,000 luminosity here, maybe about 1,500 maybe. So Neptune, yes, 24 degrees. It is in the habitable zone in its current form. Okay. But again, let's try and get the radius. I think it's the radius. When you upgrade the radius, I think that's when it starts making the sun pop. It doesn't like it when you do that. So we have to be kind of fast with it, but I think what we'll have to sort of do anyway is just sort of instantly change it to a white dwarf, because we're not going to have a nova, a supernova, because that's not what would happen with the sun anyway. So we're just going to make it pop down to a white dwarf. So, I mean, in theory, the sun would go something like this. So, see, all theories kind of say that it won't engulf the orbit of the Earth, so it's not going to reach 1 AU. That's just not really possible with the sun sort of size. So if we compared it to, say, larger stars like Antares, it's never going to be a supergiant size. It's only going to be a regular red giant. And obviously Canis Majoris, a hypergiant. Like, it's never going to be reaching the orbits of Mars, Jupiter, anything like that. So, yeah, the sun... most theories sort of think Earth will survive the red giant sun, and the red giant sun will probably roughly get just under the size of Earth's orbit, and also it will probably push Earth out anyway. So this is kind of what you'd end up with Earth. But obviously, as the sun eventually fades out, because obviously there's no point running the simulation. This is as far as we're going to get, really. So what we need to do is replace. And we need to go for a white dwarf. So, do I have what? Yeah, okay. White dwarf. There you go. So the sun puffs all the way down, and all that's left is its core. All of its outer layers are released. So, there you go. And now the solar system will be in darkness. But as it releases its outer layers, any sort of minor object, the asteroid belt objects will probably be disintegrated by this. So we're just going to get rid of those for simulation purposes. So, because we don't need them anyway. So yeah, we're just going to assume that the sun's material spray would just delete those. Earth and Mars we're going to have survive for the purpose of the simulation. We're going to delete all particles. Press play. And there you go. Oh, how did that work? Oh, where did they go? I know everyone's just flown away. We didn't press auto orbit, did we? Hey, but there you go. I mean, after a long period of time, the objects would eventually break away anyway. But let's just go ahead and run that again, because yeah, we need to look at the proper stuff. So there we go. Did we save it with the expanded system? I think we did, didn't we? So where's Earth? Is it roughly about 1 point? Yeah, okay. So again, the sun. I've got to delete all the asteroid belts again. We'll just leave them. Right, replace object. White dwarf, yes please, thank you. Go all the way down. Simulation. Open this. I know it's going to upset our outer orbits, but I mean, there's not much we can do. Auto orbit there. And that's really the best we can sort of do, honestly. So there we go. But obviously, it's lost a lot of mass, so the orbits in theory would change. They wouldn't just stay perfect where they were. So, press play. There you go. See how that... Although it has roughly played out. Okay. So, there you go. Alrighty. So, Earth. The sun has just popped. The Earth is still obviously boiling hot, but there's now no light source anymore. If we just turn all this off, I mean, where is the white dwarf anyway? There it is. So, you know, it's not gonna really. So if we just let time play out, you can see the temperature on Earth. It's gonna cool down pretty quick. So we look over here. So there you go. So whatever's left of the Earth at this point, this is how it's gonna sort of just cool down. So it's just gonna be a barren, frozen wasteland. Effectively, I mean, there's no water left on the planet, so no water would return. I mean, yeah, no water. There's no water at all, so it's just going to be a barren, frozen desert. Nothing going on here. Temperature is just going to completely drop until it goes to absolutely nothing. I mean, it's receiving barely any light anyway from the white dwarf, and obviously that will fade after a long period of time anyway. If we look at the zone, I mean, white dwarf zone is nowhere near. Yeah, look, it's just a tiny little thing, so poor old Earth. Nothing left. So the planet once would have been nice and blue. It's just an absolute scarab, an absolute just waste, and just ruined. So yeah, nothing left there. So it's just completely scorched. But now it's just slowly going to fade into the darkness. It's the same with Mars. So where's Mars? I mean, Mars in theory would still look the same way as it does now. There's no continental drift on Mars, so. Yeah, I mean, actually, you know, in theory, its surface would have melted, so maybe it would look slightly different to the way it does now. But yeah, that's all that's left of Mars. Obviously, the atmosphere and all that would be long gone at this point. Where's the atmosphere still on it? Oh no, the atmosphere is gone. That's just the clouds being weird. Actually, no, never mind. Let's just go ahead and get rid of that. There we go. That's how it looks. So something like that. And 0 there. There you go. No atmosphere for you. Okay, and that's still receiving a bit of light. But then if we go to Jupiter, I doubt anything over here. Pitch black. Yeah, nothing at Jupiter. So if we look at the orbits now, so for a while they probably still would orbit the white dwarf, and I'm talking for probably a long while. You know, it's going to take a long while for orbits to start decaying, but eventually the furthest out objects, for instance, these guys, Sedna, Planet 9, they'll be first to go. They're the furthest out. They'll break away first. So for instance, if we were to increase its speed, in theory it will just, you know, break away. Same with Sedna. They'll break away from what's left of the sun until they just sort of fly away like this as they start going somewhere else in the Milky Way. So they'll just fly off. So we go all the way down here again. Same thing with all of these objects. So we'll just do them sort of one by one. So there's Iris gone. Also all of these guys. Again, they're just going to break away. So Haumea, as the sun just loses all its pull, it's cooling down, it's lost its mass. It's not going to hold on to anything anymore. The outer orbits start going to break away. And this is a long period of time after it becomes a white dwarf as well. So gravitational sort of decay or interactions with other interstellar objects. So again, Pluto, you're going to fade out. So we're going to do that. And yeah, none of them left. So if we put trails on, there you go. They're all going bye-bye. And then again, the first of the planets, Neptune, will start to eventually break away from its orbit around the sun as well, until it eventually just completely goes, as it increases its speed or whatever, it will just completely break away from the orbit of the sun until it just goes like that and flies off. So again, same with Uranus. So there you go. So these are all too far away. As soon as their orbits sort of decay, they're just going to fly off. They're not close enough to the sun to sort of go anywhere else. So all of these objects are just going to completely go. We'll just delete that because we don't even need that. Again, Saturn, due to the original sort of known objects back in very, very old times, again, they're just going to fade off as well. Saturn's gone. Jupiter's also going to fade away. So there you go. They're flying off. Right, so all that's left is the inner solar system. And remember, the asteroid belt objects would be gone at this point. They'd be destroyed by the sun, sort of material loss as it becomes a white dwarf. So all that's left really is Earth and Mars. They're the only things that will stay loyal to the remaining sun's white dwarf in the middle, because they're close enough to hang on a lot longer than everything else. So everything else is just long flown away. So for a long, long period of time, it will just be Earth and Mars while all of these guys are gone. So all the way down here in the just depths of the far, far future. So now there's multiple things that could happen here. Either all of it will be dissolved into a black hole, or if they somehow survive any black hole interactions for all that time, eventually the Earth and Mars orbits will decay and eventually fall into, I mean, I don't know if it'd still be a white dwarf at this point. Maybe it'd be a black dwarf, so maybe we need to turn the temperature down. So maybe, I mean, can we even cool it down any further than that? Okay, well, it's dimmed down anyway, so, I mean, it'll take a long time for the white dwarf to dim down, but eventually their orbits will decay, and they will just crash into the white dwarf. So if we go all the way down here, and this is billions of years as this slowly happens. I mean, it's not a quick process. Again, same with Mars, that will slowly dissolve down as well. So again, Earth, you're just going to go all the way down until it's basically right in the face of the remaining white or black dwarf at this point. So again, Mars, Earth, they're just going to fade all the way down until they're basically going to dissolve or crash into the remains, the wreck. So obviously Earth in theory would be first. So let's see how this sort of plays out. So the collision with the whatever the hell's left of the sun at this point. So there you go. So it's just going to go into the, yeah, ooh. So gravitational radiation, just going to dissolve all of these guys. So again, Mars, I mean, I don't think it would work exactly like this. I mean, Earth would probably be first as it slowly gets, the closer you get, the faster you go. So there you go. Maybe it'll get torn up by Bruce limit. There you go. There's a good example as well. Maybe it won't actually collide. Maybe it'll just get shredded up. So by whatever's left of the sun. So that's all dissolved. There you go. And then obviously the same fate for Mars. Whoa, look at this. Ooh, so that's been ruined as well. So yeah, that's what's ever's left at this point, because this is just trillions of years in the future at this point. So again, Mars, going to do the same with you. So they receive temperature one more time in their lives. Right as they die, they will receive temperature one last time, as if they even survive to this point. Because remember, at this point, anything could have happened to the solar system. Black holes, other interactions with stars. Maybe a new star forms and takes over. Who knows? But yeah, slowly Mars will just creep down like the Earth did, and eventually just fall in as all this gravity, just all these orbits just fail, and they all just fall into the sun. So again, Mars, you're just going to just fall in as well. So again, let's put it in the Roche limit of the remaining sun. So there we go. Any second now, it's going to start being shredded up as Mars goes into the Roche limit. Is it being torn up? I don't know. Oh, how is it still hanging on in there? Earth got torn up. How's Mars still going? Maybe it has to go even closer. Oh, well, maybe Mars just falls in. Maybe its orbit just completely goes boom. And there you go. So that, a theory, is the end of the solar system at this point. And obviously, white dwarf sun. I mean, that, I don't know. This Earth should be long gone as well. Just get rid of that. Get rid of all these particles. So no more systems left. And then eventually, the white dwarf would either just, well, it'd be black dwarf at this point. So either this would just explode. Well, not explode, but just wither away, you know, just dissolve, or it'd get eaten up by a black hole. So we'll go with the dissolve route. And do we just explode it? Oh, that makes a nova. But yeah, that would just turn into nothing, basically. So there you go. That's it. And then no more solar system. And then same with all the planets that escaped. They'd either get eaten up by a black hole in the far, far future, or they'll just dissolve as well, but for the convenience of this simulation. Maybe a big black hole just sort of flies by everything, so maybe it just eats them all up. But I mean, by this point, all these planets would be all over the galaxy if they just keep traveling and don't run into anything. So maybe if we go to actually spawn in a Milky Way and place it sort of, I don't know, there. There you go. And just watch as all the remaining planets or whatever just get taken who knows where in the galaxy. So there you go. Let's just let it play out really far now. Just watch as the planets all just sort of spray out and they just get slung around the Milky Way. Maybe they get ejected from the galaxy. Maybe they don't. But, I mean, by this time, it won't even be a Milky Way, will it? It'll be Milkomeda. So, there you go. Remember, Milky Way and Andromeda would have collided while the sun's becoming a red giant. So, yeah, theory of the planets would all be shredded around. They'd never see each other again. They'd be all over the place, and they'd either get eaten up by black holes or taken over by other stars, whatever the universe is like in however far in the future this is. So, yeah, there we go. But that's just our little take on it. So, there we are, guys. That does it for evolving the solar system from the present day to death. So I hope you enjoyed this sort of two-part series, and yeah, if you did, make sure to hit that like button. If there's anything I missed, let me know down below in the comments. Is there anything we could have done different or changed, or is anything I missed? Yeah, anything I missed, or how do you think things will go? Let me know down below in the comments there. And yeah, let's even go for 60 likes on today's video, guys, and subscribe for more. Helps on the journey to 27,000 subscribers. And with that all said and done, guys, make sure you have a great day. Stay safe out there. Stay tuned for more videos, and I'll see you in the next video. Goodbye.